Welcome back once again. Again, we are learning to solve the techniques regarding turning effect of the forces topic. And after this, we have calculated tension in case waves are acting vertically. And we are asked to calculate the tensions in different positions. So, moving forward, nut has been tightened by a force of 200 Newton using 10 centimeter long spanner. What length of a spanner is required to lose the same nut with 150 Newton force, 13.3 centimeter? So how will you calculate then? What will be your technique to calculate? First of all, you will consider the first force, that is 200 Newton. Then you will see at what the distance, what is the moment arm at that time in meter. Then you calculate the force, and the force formula is this one. And when you are using 200 Newton force and the moment arm is 1 meter, then this will be your torque produced. But what if you are asked to calculate the moment arm, then only calculate the moment arm in the other case. So if you are increasing the force by 50 newtons, so here is the formula. So ta is equal to, that is F force multiplied by moment arm. So if you look at this one, this moment arm is equal to star divided by force. So what was the torque which you have calculated? This torque is produced basically 50 Newton. So you have to see what will be the force acting at that time. It will be 150. And what will be the momentum it is given? You are given that such a force is acting. Same, the spanner, what length of the spanner is required to loosen the same nut with 150 Newton? Very simple. First, the force is given, momentum is given, you calculate the force. If you are increasing the force for the same spanner, what length is required, then you are calculating this is the force torque produced in case of 150 Newton. And what about the 150 Newton, 200 Newton, this one? And what about the 150 Newton? You have placed the value and finally you have calculated how much length of the spanner is required. It means if you look at this technique, sometimes you are given how much force is required. You calculate the force if you are given moment arm. Sometimes moment arm is given, length is given, you are asked to calculate at such length what type of the torque will be produced. But if the torque is given and the force which has produced the torque, it is also given, then you will be asked to calculate how much length of the spanner is required to produce such type of the torque. So here is another problem, which is a block of mass 10 kg suspended at a distance that is 20 centimeter from the center of the uniform rod at 1 meter long. What force is required to balance it at center of gravity by applying the force? This is this type of a problem. If you look at, this is the point of rotation, and to one side the forces are acting, to the other side if you look at this one, and to the other side again we are applying some masses are hanging, you will convert into the mass. So you are asked to calculate the clockwise torque. Look, what is the what force is required to balance it at its center of gravity? Suppose this is the point at which you have balanced it, and you must have performed experiment in the lab. You were asked to calculate to prove the moment principle of the moment. So this is the principle of moment. Clockwise torques are equal to anti-clockwise torques. So what here it is M1. Here it is R1. Suppose this one is M1, then the distance of this M1 from the CG will be R1. So here it is M2. So the distance of M2 will be R2. If you multiply this mass of the force after calculating force with the moment arm, that is R1, then you will be able to calculate the moment clockwise torque. And similarly, the case in case of the M2, it will be R2. And this one is R2. You have calculated. So you are asked how much force is required. What force is required to balance it at center while applying the force at the other end of the bar. So you are asked to calculate M2 force. M1 is given. So you will put the value F1 R1, that is F2 R2. Now the force is calculated by multiplying mass with the, basically these are W1 and W2. You are asked to calculate F2. Then this is principal of moment. If it is balanced, then the torque acting along its right side must be equal to the torque acting on the left side. So this is the formula. F1 multiplied by R1, that must be equal to F2 multiplied by R2, and you have placed the values in the formula. Finally, you have calculated this is the amount of force. If this force is applied, you have applied the basic condition to balance the forces. So you have applied the basic principle of moment. So this is clockwise torque is equal to anti-clockwise. This one is clockwise. This one is anti-clockwise. If these are balanced, and this will be the condition. Then all other forces are given. This force is acting at zero point 0.5 meter, and this one was acting at zero point 0.2. And it's 100 Newton. So you have calculated the amount of force required to keep apply to the M2 side to keep it balanced. So this is the technique to calculate. So with this, today's class ends, and hopefully you have understood how to solve the problems in case of turning effect of the forces, what amount of the forces, if what is the concept of application, how you, which type of the formula is used, and when it will be used. I hope you people have understood to apply some of the conditions to calculate the turning effect of the forces. I thank you all for your patience.